Hello everyone, I welcome you all to my YouTube channel. In my last video, I've covered the entire theory of Polynomials chapter. So if you haven't watched that video, first go and watch that video. In this video, I will be covering the important questions of Polynomials chapter. So let's start. The first question is, in this you're given a polynomial and alpha and beta are the roots of that polynomial. You have to find a polynomial whose roots are some expression in the form of alpha and beta. In this case, alpha square upon beta and beta square upon alpha are the roots of an unknown polynomial. We have to find that polynomial, where alpha and beta are the roots of this polynomial. Solution is, I told in my last lecture that polynomial can be represented as x square minus sx plus p equal to 0, where s is the sum and p is the product. Al so alpha plus beta is equal to 4 by 3 minus b by a from here, and alpha into beta is equal to c by a, product of roots 1 by 3, right? New sum of roots will be alpha square upon beta plus beta square upon alpha. So taking the LCM, we'll get alpha cube plus beta cube upon alpha beta. You must be knowing this identity a cube plus b cube is equal to a plus b into a squared plus b square minus ab. So I've used this identity replacing a by alpha, b by beta. You get this value on substituting a by alpha and b by beta. And I simplified this expression. Alpha squared plus beta square can be written as alpha plus beta whole square minus 2 alpha beta. So on some further simplifying, I get minus 3 alpha beta here. Now I know the value of alpha plus beta and alpha beta from here. So I'll substitute it and get the value of alpha cube plus beta cube. And substitute in this expression new sum of roots. I'll get alpha cube plus beta cube value and alpha beta value. So I'll get the new sum of roots. The new sum of roots, I've solved it for alpha cube plus beta cube, the value of alpha cube plus beta cube. I get 28 by 27. So new sum is this. I substitute the values. So I get the new sum as 28 by 9. And new product will be the product of these new roots. This is, on simplifying, I get alpha into beta, which is 1 by 3 we know from the first expression. So the new polynomial will be x square minus sx plus p. S is 28 by 9 and p is 1 by 3. So this is the polynomial, or any multiple of this can be the required polynomial. Why? Suppose I have multiplied with 2, then also the polynomial will be equal to 0 only. If I multiply with 100 also, then also the roots will be the same, because this will get divided by 0 and become 0, right? So let's go to the second question. Second question is, if on the similar basis, let's try one more question. So alpha and beta are the roots of this polynomial. Find a quadratic polynomial whose roots are 1 upon 2 alpha plus beta and 1 upon 2 beta plus alpha. I've taken this question from R.D. Sharma exercise. You can refer that book, right? So alpha plus beta is equal to 3 and alpha into beta will be equal to minus 2 from sum of roots and product of roots. The new sum, required sum, will be 1 upon 2 alpha plus beta plus 1 upon 2 beta plus alpha. I simplified it taking the LCM. 2 beta plus alpha will go here, 2 alpha plus beta will go here, and in the denominator we'll take their product. On adding, I get 3 alpha plus beta into their product in the denominator. 3 I have taken common, 3 into alpha plus beta. I have simplified the denominator. On further simplification, I get 3 into alpha plus beta upon 2 into alpha square plus beta square plus 5 alpha beta. I have calculated alpha square plus beta square from here. It will be alpha plus beta whole square minus 2 alpha beta. This is a famous identity you must be knowing. Alpha plus beta value we know and alpha beta value we know. Substituting these values here, 9 square and minus 2. So minus 2 into minus 2 become plus 4, 13. Alpha square plus beta square become 13. And I've substituted the values. Alpha plus beta is 3. 3 into 3, 9. 2 into 13 plus 5 into minus 2. You get 9 upon 26 minus 10. So on simplifying, I get the sum as 9 by 16. Now I'll find the product. Product is 1 upon 2 alpha plus beta into this expression. Simplifying the denominator again, we have already simplified in the sum. You get this. On further simplification, you get product as 1 by 16. Again, the polynomial will be x square minus sx plus p. S was 9 by 16, P is 1 by 16. So any multiple of this quadratic polynomial is can satisfy the answer, right? So next category comes mixing AP and polynomials chapter. This is one of the categories in this chapter. Here we mix that. This is arithmetic progression. This is one of your chapter in your book, NCERT textbook. So what is an AP for those of you who don't know? AP is a sequence of numbers where where the difference between the consecutive terms is constant. Like in this case, first term is A, second term is A plus D. So A plus D minus A will be D, right? A plus 2D minus A plus D. Difference will be D. So the difference remain constant in an AP. Examples of AP are 2, 4, 6, 8. The common difference is plus 2. Just subtract the lower term from the higher term. Means the term which come first, right? 7, 11, 15 is again an AP with common difference 4. 11 minus 7, 15 minus 11. So selecting three terms in an AP. A minus D, A and A plus D are generally selected three terms in an AP because the common difference is D, and when you add them, D gets cancelled. You get 3A when you add them. So this is an important trick which is used in polynomials chapter. So if you have to select four terms in an AP, you select A minus 3D, A minus D, A plus D, and A plus 3D. You select these three terms when generally when a cubic polynomial is given and its roots are in AP. So you select these. You will get the sum of roots as 3A, and 3A will be equal to minus B upon A. From the coefficients of polynomial, you get the value of A. Don't get confused with this A and the coefficients of a polynomial, right? That A is different, and this is just a, you can mark this with A dash for the difference, right? And in biquadratic, you can assume that again, if you add them, D will get cancelled, you'll get 4, right? So I'll show you one question. So this is one of the questions. First, I have taken two questions. First question is from NCERT, and this second question is from RD Sharma. You see how the books manipulate the questions. This is a polynomial given, and it's given in the NCERT that these three are the roots or zeros of this polynomial. Then we have to find A and B. Finding A and B means finding the roots of this polynomial, right? If you find A and B, you'll find the roots, right? And by seeing this, we get to know that roots are in AP and common difference is B. Just now I showed you. Just they have replaced D by B, right? And in RD Sharma, they have said that find zeros of polynomial if given the zeros are in AP. So the concept is same. I'll solve one question. I'll solving this one. I've taken three roots. Because it's a cubic polynomial, A minus D, A and A plus D, alpha, beta, and gamma analogies, right? Uh, I hope you understand this. We have to select three roots, so I'm selecting these one. The reason I've already given because when I add them, sum will become 3a, and I know the sum of roots is 12 minus b upon a from here, right? So I get 3a equal to 12. Don't get confused with this a and this a. This a is this coefficient 1, and this a is the terms of the AP. You can take some xyz also if you are getting confused. So 3a is 12, a is 4. So the roots become 4 minus d, 4 and 4 plus d. The product of roots become a minus d into a plus d. And product of roots I know from here is minus b upon a, c upon a, minus d upon a. Minus d upon a means 28. Right? Product of roots is 28. A value is 4. So I'm multiplying these two terms first. I've marked it also. Using the identity, it becomes a minus a square minus d square. It becomes 28 by a. A is 4. I have substituted the value. A square, it becomes 4 square. 16 minus d square becomes 28 by 4. On solving, d square comes to equal to 9. So d is plus minus 3. Take any value, it will not matter. Suppose I take plus 3. This roots become a minus d, a and a plus d. A is 4, d is 3. So roots become 4 minus 3, 4 and 4 plus 3. Roots become 147. If you take the other value, roots will come in just the opposite order, 7, 4, 1. But the order does not matter in the roots, because if 2 and 1 are the roots of a polynomial, then 1 and 2 are also the roots of the polynomial. So order does not matter. So, right, so we have solved this question based on AP. Now I'm showing you another type of questions. In these questions, two zeros of the polynomial are given. We have to find the third one in case of a cubic polynomial. A cubic polynomial is given and two roots are given. We have to find the third zero. And a similar question is based on this. If a biquadratic polynomial is given and two roots are given of the biquadratic polynomial, we have to find the other two roots. So you must be finding these two questions very similar, right? So this was question was asked in your board exam CBSE 2010, and this is in your NCRT. So questions in board generally come from NCRT. You can see from it. There are two methods to solve this question. The first method is I'll show you. For the first question, we'll apply the first method. Alpha is root 3, beta is minus root 3, given two roots. We have to find gamma, the third root. See this alpha, beta, gamma, just the denotation. You can take this also as gamma and this also alpha. Any three of you can any three you can take in any order, right? Order does not matter. So you know the product of roots is this is the polynomial. So minus b upon a, c upon a, minus d upon a. So the product of roots is minus 12, and two roots are given. Root 3 into minus root 3 into gamma will be minus 12. So this becomes minus 3 and minus 12. So I've cancelled minus from both sides. Gamma become 4. So the third root is 4. See, simple, right? It's very simple. If you find the video very fast, you can just go through it again. You'll get it. The question is very simple, right? Now I'll show you the second one. Second method is based on division algorithm, right? Which I told you in my last video, right? So the second method is I told you that a biquadratic polynomial can be factorized into its root in this way. Suppose alpha, beta, gamma, and delta are the roots of the biquadratic polynomial. So it can be factorized at the highest power term coefficient is taken out a into the factors x minus alpha, x minus beta, x minus gamma into x minus delta, right? So we are given alpha is 2 plus root 3, beta is 2 minus root 3, and the roots of this biquadratic polynomial. We have to find the other two zeros, gamma and delta. So x minus alpha is a root, so x minus alpha is a factor, right? If x minus alpha is a root, then x minus alpha is a factor of that polynomial. Similarly, x minus beta is also a factor of a polynomial because x equal to beta is a root given, right? So using this expression, this one, I'm going to factorize this on similar basis. Here a is 1, right? So it will be written into x minus alpha into x minus beta into x minus gamma into x minus delta, right? So I'm writing it here. I've written it like this. So x minus gamma into x minus delta will be dividing these two here, taking these two on the left hand side. So I've written the value of these two. The product of these two is this polynomial divided by these two, right? So I'm calculating x minus alpha into x minus beta because I know the value of alpha and beta. Alpha is 2 plus root 3, beta is 2 minus root 3. Open it. Write it as x minus 2 minus root 3. This minus will be distributed, and here x minus 2 plus root 3, right? So opening this becomes this. Now take this as a x minus 2 and root 3 as b. Here also x minus 2 as a and root 3 as b. It becomes a minus b into a plus b. I hope you have got it. Uh, this is taking the form of the identity a minus b into a plus b, where a is x minus 2 and b is root 3. So it will become a square minus b square, where a is x minus 2 and b is root 3. So x minus 2 square minus root 3 square. On simplifying, x square plus 4 minus 4x minus 3, right? So it becomes x square minus 4x plus 4 minus 3 is 1. So x square minus 4x plus 1 is equal to x minus alpha into x minus beta. So I'll substitute here the value of x minus alpha into x minus beta, which I obtained. So I'll get the value of this product, right? So I'm now using the division algorithm. This is x minus alpha into x minus beta. This is the polynomial. I'm dividing it. This is the division algorithm. I hope you must be knowing this. So I'll cover it fast. So first we multiply by x square, you get x4 minus multiply the remaining terms with x square and changing the signs, right? So this is plus, so minus goes to plus, plus goes to minus. These terms will get cancelled. Minus 6 and plus 4 minus 2x cube. This is minus 27x square. Just on the similar basis, you can study the division algorithm if you don't know. Now we'll multiply with minus 2x, so it will become minus 2x cube, right? So aim is to get this. On solving, you'll get that remainder comes as 0. So remainder comes in 0 and quotient come this x square minus 2x minus 35. So question comes this, and this is equal to x minus gamma into x minus delta. I've already shown you here, right? See, on dividing this, I'll get x minus gamma into x minus delta. So x minus gamma into x minus delta come as this. I'll factorize this. This 2 can be written as minus 7x plus 5x. Factors come x minus 7 and x plus 5. On comparing, I get gamma as 7 and it can be written as x minus minus 5. So delta is minus 5. The other two roots I found, right? So this forms an important question in your board exam. Uh, I hope you've got it. Just check the division algorithm once slowly. I'll show you here, right? You can pause the video and see it. Okay. So, right. So these are the questions you can try on the similar basis they have been asked in the board. I've gathered. See, this is a polynomial, biquadratic polynomial. Two zeros are given. You have to find the other two zeros. Just we did it, right? So this was asked in CBSE 2008. On in this, I don't know, in some other set it was asked the same question. Just they've changed the coefficients and the roots, but the concept is same. Again, this question was asked in CBSE 2009 also. Here a cubic polynomial is given, category 1 of question 4 I explained you. Two zeros are given, find the third one. It's very simple, product, use the product, you'll get the third one. A similar question was asked in another set. Two zeros are given and you get the third one, right? So this comes, by this I come to the end of the video. I'll be posting more important questions in the upcoming videos. So please like, share and subscribe to my channel to get more recent videos. And I'll cover the complete polynomial chapter from all the books and all important questions. Okay then, goodbye. Take care.